Hey guys, today I'm going to solve a problem of electric field due to multiple point charges. So here's the question, and it asks us to find the electric field produced by this ring with a radius of big R and uniform charge big Q at a point P, which is on the axis of the ring at a distance small r from the center of the ring. So first of all, let us divide the ring into n pair of diametrically opposite small portion of charge, each having delta q charge. So since I have 2n, delta q would be big Q, which is the total charge divided by the number of points that I take. And now each point act as a point charge for the point P. So each will have electric field. For Q1 that I have labeled as first point has a electric field E1, which could be written in this form. E1 is 1/4πε0 delta Q over R1 cube times R1 vector. And for Q2, which is the another point, we will have E2 electric field going into this direction, which expression is written down here, 1/4πε0 delta Q over R2 cube times R2 vector, which can be written in this form. Now by electric field due to multiple point charges, we can find the resultant of these two, E1 and E2 electric field, which is be in between those two going into this direction. So the resultant would be E1 plus E2, and add the two expression E1 and E2 by simple algebra we get this form, and the direction of the resultant of these two would be along the axis of the ring, which is on the x-axis. So here I have only taken two pairs, a pair, 2 points. What if we have more than one pair, let us say 2 pair, 4 points? Any other pair on the ring would produce the same electric field, equal in magnitude and in direction toward this resultant right here. So by electric field due to multiple point charges, no matter how many number of pairs you have, the resultant E by this whole ring would be sum of the electric field by those number of points. So if you have n pairs, or n number of points, n times resultant of these two pairs right here. So by simple algebra you get this equation right here, or this expression. So now we have calculated the electric field by this ring. This example right here provides an algorithm to calculate the electric field of any charged object or with arbitrary form and uniform charge distribution. For example, this is a ring. You can have a rod with small n division along the line of the rod. So how can you do that? Well, we just need what we need to do is we need to divide whatever the object we have into small n pieces, and then apply electric field due to multiple point charge using numerical integration by the help of computer over the volume of the object. So if you have a rod, you would divide that rod into various small units n. You can divide that into 100, 200. More the number of n, higher is the accuracy of the electric field, and you can calculate, you can sum the integral of all the electric field using a computer. Here I'm using VPython as my computer program to calculate the electric field of the ring we just had. So this is the code I have written for VPython. And first of all, I define my constant. This is 1/4πε0, and the charge would I have assumed to be 50 times 10⁻⁹ coulomb, and the radius would be 0.3 meters. Let us say the observation location on the question I had on x-axis. Here I'm defining all three x, y and z axis, and on the question I have number of division as 2. I'm dividing it into 500 pieces, and this is the expression I had. So when I run this program, you get this is the field, electric field vector in x, y and z direction. You can see, you can calculate for 500 number of division, and this is the magnitude of electric field. As you can see, I have printed the field vector and the magnitude of field. So this is the example of the this is one example of the calculation where you calculate just for 2 points, but using computer programs such as VPython, you can divide that points into 100 to 100 point divisions and then get more accurate electric field. Thank you.